Hello dear students, welcome to Pen and Paper Chemistry on YouTube, and you know that we deal with topics in organic, inorganic, physical and general. With this video we start the topic of carboxylic acids, and we shall be dealing with preparation properties of carboxylic acids. In my earlier video, I had shared this flowchart with you for the preparation of carboxylic acids and requested you to share your work through this Google form, my work on carboxylic acids. Thank you to those who have responded. The form is still open. Please go ahead and share the equations that you write based on this flowchart, and maybe even get a feedback on your work. When we do the preparation of carboxylic acids, of course we are going to refer to this chart again and again, so you can keep it handy and keep it on the left side or the right side of your notebook so that we can refer to and understand what this chart stands for. As you can see, the arrows are pointing from the left hand side all towards carboxylic acids. That means this part of the flow chart indicates preparation of carboxylic acids by various methods. Alcohols, aldehydes and acid derivatives all can be converted into carboxylic acids by various methods. We are going to start with the first one, that is conversion of alcohols and aldehydes to carboxylic acids. So, are you all ready with your pen and notebook so that we can together write the equations for the preparation of carboxylic acids? To write the preparation, simply understand the logic. Alcohols, aldehydes and carboxylic acids, what is the relationship between them? Alcohols on oxidation give you aldehydes, aldehydes on oxidation give you carboxylic acids. If you use strong oxidizing agents, then even alcohols can get converted to carboxylic acids. Only thing is you have to use a strong oxidizing agent so that alcohol to aldehyde to carboxylic acid. So, you see you need oxidation at two stages, so that is why a strong oxidizing agent would directly convert an alcohol to a carboxylic acid, whereas a mild oxidizing agent will convert aldehyde to carboxylic acid. Now, if you try and recall, when we talk about strong oxidizing agents, we had given a list, right? So, you have acidic, alkaline or neutral potassium dichromate. We also used acidified, alkaline, neutral potassium permanganate. Now, any of these can be used to convert alcohols to carboxylic acids. Aldehydes can be converted to carboxylic acids even by mild oxidizing agents. Now, for this, try and recall what you did in aldehydes. There was a certain test for aldehydes which you did. Remember this test? Yes. So, even mild oxidizing agents like Tollens reagent, Fehling solution can also convert aldehydes to carboxylic acids. Now, what do you have to do? Yes, you have to write the equations for the same. So, we have over here RCH2OH, that is a primary alcohol. Yes, everywhere we are talking about primary alcohols over here. Let me write it more specifically, right? Primary alcohols get converted into aldehydes and aldehydes to carboxylic acids, right? So, RCH2OH, CH2OH means we are talking about a primary alcohol to an aldehydic group CHO to a carboxylic acid COOH. Now, try writing the full equation for the conversion of ethanol to carbon atoms. So, eth, ane and all, ethanol. What will be the products formed? Go ahead, Pause the video, write the reactions. Yes, it will be good to try the reactions yourself. So you see over here, it is the CH2OH group which gets oxidized and gets converted into CH3COOH, which on further oxidation gets converted into CH3CHO in the first stage, that is ethanol or acetaldehyde, and acetic acid or ethanoic acid. Now, there may be some of you who must be struggling or who would be struggling. I am not saying all of you. If you are not able to relate to the words that I am using and how to go about it, I would suggest that you start from the beginning. I have uploaded a separate playlist on IUPAC nomenclature on the same channel, right? Pen and paper chemistry. And then we have the mechanisms, the basic principles, right? So, basic principles of organic chemistry. Once you are done with these videos, you will definitely be smiling because your basic fundamentals, your ABC of organic chemistry would be clearer, and you will be able to understand the words that we are using over here. The reagents, the oxidizing agents, as I said, acidic, alkaline or neutral KMNO4. Also, please write over here, primary alcohol. We teachers assume a lot of things, so I think it is better to be specific. Again, acidic, alkaline or neutral potassium dichromate, aldehydes on oxidation with mild oxidizing agents will also give us carboxylic acids. And what are those mild oxidizing agents? Yes, Tollens reagent and Fehling solution. We have dealt with Tollens reagent and Fehling solution in our previous videos, wherein we dealt with aldehydes and ketones in a lot of detail. Please refer to it to clear any of the doubts that may be cropping up. Now comes the second preparation, that means from acid derivatives. What are acid derivatives? Let's understand that first. Preparation from acid derivatives is very easy, because what we have to do is we have to hydrolyze them in acidic or alkaline medium. Hydrolysis, hydro means H2O, lysis means breaking down. You break it down with the help of water. As simple, it's a very easy way of understanding, okay? I'm not talking about mechanisms as yet. Carboxylic acid derivatives. What are the derivatives of carboxylic acids? So, you have over here RCOOH, right? You replace the OH by a halogen, most commonly it's Cl. So, then it becomes an acid chloride. You replace the OH by an OR dash, that is alkoxy group. It becomes an ester. You replace the OH by NH2, right? Everywhere I am replacing the OH, okay? You replace the OH by NH2 and I have an acid amide. By the way, these are all common names. These are not IUPAC names. That is why there is no acid in this ester, right? And you replace the OH by a carboxylate group. So, RCOO group, right? And we have what we call as an acid anhydride. Now, there's a logic to it. Anhydride means which has lost water, right? So, RCOOH, remove the water, connect the two molecules and we have RCO, and this is the bridge between the two. That is, oxygen is linking the two molecules together, giving them the a single structure, what we call as an acid anhydride, right? So you have 4 of these acid derivatives. In the same flow chart, I have converted the carboxylic acids to each of these derivatives, acid derivatives. So carboxylic acid to ester is by treatment with an alcohol in the presence of an acid. Yes, we all know this experiment from our grade 10 study as well, where we said that this reaction is known as esterification. It's a reversible process, right? So it is done in the presence of an acid. Same way, to convert a carboxylic acid to an acid chloride, what do I do is I treat it with PCl5, or we can treat it with SOCl2. There are many ways. These are simple ones that I am discussing. So it gives us acid chloride. Third, how to convert it into an acidamide? Simply by treating it with ammonia at high temperature. So the OH gets replaced by the NH2 group. Fourth, again you heat it in the presence of a dehydrating agent like phosphorus pentaoxide, and you get acid anhydride. In all of this, what you are doing is you are getting rid of the OH group. If somehow I can add the OH group back, I will get the acid, right? And that's exactly what we are going to do in the preparation of carboxylic acids. Acid chloride plus HOH, hydrolysis, and that hydrolysis takes place in the presence of an acid or alkali, H positive or OH negative. Oh yes, you've already written the reaction. Very good. So what I'm going to do is I'm going to make a simple box over here so that it's easier for me. And I get over here RCOOH and HCl, as simple as that, right? Now would you like to complete the second reaction, that is acid chloride, actually more exactly acetyl chloride, or IUPAC name, ethanoyl chloride, right? More of that later. Make a box and write down the products of the reaction. Don't forget to write the reaction condition. Same way, acid anhydride, we had removed water from an acid to get acid anhydride. We'll add water to get the acid back. There you go, RCOOH, right? Oh, there's something wrong in my structure, right? Can you figure out? See, where have I gone wrong? Is it correct? Is it wrong? Have a look. Can you point out the mistake? Yes, see, RCOOH, RCOOH. I remove water, right? What do I get? RCOO, RCO, and there's this linkage, right? What have I written over here? RCOO. How many oxygen have I written extra? Yes, so good to correct myself over here, and I will have RCO, RCOO, and water. I think now it should make sense, right? RCOOH and RCOOH. Good, thank you. Yes, thank you for paying attention there. Yes, you must be wondering that earlier I just took RCOOH and here I am taking this oxygen. That's okay. One of the oxygen can go with the hydrogen, the other RCOOH. So basically you're going to get 2 molecules of the carboxylic acid here. Go ahead. Now write down complete the next reaction, that is acetic anhydride, CH3CO whole twice O. What is this CH3CO whole twice O? Teacher, why are you confusing us? Don't worry, I'm going to make it easy. See, CH3CO whole twice, I have written the whole twice, and they are connected by oxygen. Isn't it easy now? And you can write either an acidic or alkaline medium. Interestingly, this reaction can even take place in the absence of these. You just add hot water and this reaction will take place, because basically acid anhydride is acid from which water has been removed. You are providing that water and you get the acid back. Esters, right, have a look at the reaction, right. Look very carefully. So, I have got an ester over here. I have taken two different alkyl groups and then hydrolyze in the presence of an acid, and we are going to write a separate reaction for hydrolysis in the presence of an alkali. You have to be very observant. Observe what I am trying to show you over here. Look at the arrow direction. Yes, it holds a lot of meaning for this reaction. So, here what we are going to get is, we are going to get the product RCOOH plus R dash OH, right, to make things simple. There we go, right. It's this RCOOH, right. Now, same way, can you form the products for the second reaction? What do these arrows indicate? Yes, that means in the presence of an acid, this hydrolysis is a reversible reaction. So, why aren't we writing a reversible arrow over here? RCOO R dash plus NaOH. Yes, hydrolysis will take place here as well. So, RCOOH plus R dash OH if I am talking about hydrolysis. So, RCOOH plus R dash OH, right. But because we have a base over here and here we have a carboxylic acid, further on in the properties of carboxylic acids, we will study that this is acidic in nature. So, what will happen? The hydrogen is replaced by the positive part coming from the base. We know that all acids react with bases to give us salt and water, right, NaCl plus H2O. Same way, carboxylic acids RCOOH react with strong bases. This is our acidic hydrogen, so RCOONA plus H2O, right. So, we are going to get the sodium salt of the carboxylic acid, and from this I can obtain the acid by simply treating it with a mineral acid. So, RCOOH plus NaCl, right. So, this is how we prepare carboxylic acids from esters using an alkali, right. Now, you have to remember over here that the reaction is not reversible when you are using an alkali, but it is reversible when you are using a carboxylic acid. That is why the difference in the arrows. Here I am going to introduce a word to you which I am sure you have heard about: saponification. What is saponification? When you carry out this particular reaction, that means reaction of esters with alkali, right. So, let me modify this and write NaOH over here instead of or more appropriately, yes, okay, NaOH. Now, that gives me the sodium salt of a fatty acid, right. Now, this particular reaction is used for the preparation of soaps. How? You need to find it out for me and maybe put it in the comment section to know whether your answer is right. Okay. Next we go on to amides. Again, from amides, acidic or alkaline hydrolysis, it's pretty easy, right? Would you like to write the reaction on your own? Yes, there we go, there we go. And what do you get over here? You get R, C, double bond O, OH. See, I can also write it as RCOOH. It becomes very easy for me. But if you are a beginner and if you are new to organic chemistry, just go slow. R, C double bond O, OH, and that gives me the carboxylic acid, right? So what will be the acid obtained in the next step? CH3COOH plus, of course, ammonia, right? The next method of preparation is from nitriles. I hope you are keeping the chart handy so that you can refer to it. Yes, see, we've already covered primary alcohols, acyl halides, acid anhydrides, esters. Now it's the turn for nitriles, acidic or alkaline hydrolysis. Again, what do you mean by hydrolysis? Yes, the addition of water. So what are we going to do? We are going to carry out plus HOH, and we are doing this in the presence of H positive or OH negative. We are keeping things simple. I'm trying to break it down so that it's easy for you to understand. Lot of times you will see me doing that. There will be no mechanism over here. H, OH and H, right? And then O and H2. Yes, this is not the mechanism, right? So what do you get over here? So first step, you're going to get an amide, RCONH2, right? And this on further hydrolysis, you get RCOOH. That is why we have used the word complete hydrolysis. We have already dealt with it in the chapter of alkyl halides or haloalkanes, because this is a very good method to convert alkyl halides to carboxylic acids or haloalkanes to carboxylic acids. But there are a number of steps involved, and you have to be very careful and observant about something that we are going to do over here. So my first step is to convert the haloalkane to the alkyl cyanide or the nitrile. How do I do that? Think. We've done it in the chapter of haloalkanes. I know it will be a little difficult to recall. I'll give you a hint over here. We had also spoken about the concept of ambident nucleophiles. Yes, there you go. We treat it with KCN, and I get CH3CN over here. Now notice something interesting. My haloalkane had one carbon atom, whereas my corresponding nitrile now has 2 carbon atoms. I can either convert it to CH3CONH2, or I can convert it into a carboxylic acid. In both cases, they have 1 carbon atom more than the original haloalkane. There's 1 carbon atom over here, there are 2 carbon atoms over here. There's 1 carbon, there are 2 carbon atoms. This is what we call as ascending the series, going up the series. Ascend, go up, add more carbon to it, right? And how do we do that? Either I can carry out partial hydrolysis, in which case I will get an amide using a concentrated acid, or I can use a dilute acid, bring about complete hydrolysis, giving me the corresponding carboxylic acid, right? Easy? Okay. Have you noted this down? Have you written it down? Because unless you write it down, you may find yourself again thinking. It is better to write each reaction at least 3 times with your own hand. So what you can do is, once you can write while you are doing or watching this video, then second time as a practice, and third time, just close your book and write it down. Preparation from Grignard's reagent. This is something that I would want you to write. C double bond O plus RMGX. There is a separate playlist only on Grignard's reagent and diazonium salts. These are very, very important compounds, very important from synthetic point of view. Please revise that before you write this reaction. I'm not going to write it. I want you to do it yourself. Lastly, we have the preparation from alkenes. So if you see over here, substituted alkenes. It's not alkenes, it's substituted alkenes. What do we mean by substituted alkenes? I will explain. And they are oxidized and hydrolyzed. So what do we do in this particular reaction is, so first of all, let's understand what do we mean by substituted alkenes, and we need to get this chart out of our way. Your alkene, your starting alkene is CH double bond CH, right? No, it's CH2 double bond CH2. We are talking about an alkene. What would be your starting alkyne? Yes, that would be CH triple bond CH. Now you replace the hydrogen by another alkyl group. This becomes a substituted alkene. You replace the hydrogen by an alkyl group. You can replace the second hydrogen also by an alkyl group. You can replace this hydrogen by another alkyl group. They may be same or different. In each case, it's a substituted alkene or a substituted alkyne. Again, there's a separate playlist on alkenes and alkynes. Alkenes, double bond between the carbon atoms. Alkynes, triple bond between the two carbon atoms. There is cleavage, that is breaking of the bond, as well as oxidation. So what product will be formed will depend on your alkyl groups which are present around the doubly bonded carbon. So where is it going to break from? It is going to break from here, and there is oxygen, and then there is hydrolysis. So we are going to put the OH and we are going to put the OH. There's hydrolysis, right? There's not exactly OH. I will try to keep it simple. So just put an O over here and O, and there we have the product CH3COOH, right? So you have two molecules of CH3COOH. Same way we are going to break down the alkyne as well. Again, oxidative cleavage, that means there is oxidation taking place and there would be hydrolysis. So RC, CH3, CH2, COOH and an OH, and what do we get over here? Write the products of the reaction. Okay, what if my original alkene was CH3CH double bond CH2? How about this? What will be the products formed here? Yes, again they will be breaking down over here. So oxidative cleavage, so we will have CH3COOH. Now if you notice, there is no alkyl group over here. So what is going to happen is this CH2 group actually gets oxidized and we get carbon dioxide and water. This brings us to the end of the preparation of carboxylic acids. Note the direction of the arrows here so that you remember that we are talking about the preparation. I have also uploaded these charts on pen and paper chemistry Google site. Yes, it's a Google site and you will get all materials on it, all your notes, all the flowcharts. In fact, I have shared the link for this in the flowchart as well. So pen and paper chemistry, lot of material which you can easily download and use. But I've named the channel Pen and Paper Chemistry just as a reminder that you need to write yourself in order to be confident in learning as well as writing your exams, so that I can have a smiling you when you come out of the examination room. I will see you in the next video where we will be taking up the properties of carboxylic acids. Till then, take good care of yourself and work hard and work regularly. See you soon.